Okay, today we're going to do our intro unit, our notes number 8. So yesterday we talked about just the characteristics of quadratic functions. Today we're going to learn about graphing them from a table. So by the end of the set of notes, you will be able to graph quadratic functions. We're going to put from a table. Tomorrow, we'll talk about how we can graph those functions just from using our equation. So let's review our 3 types of functions again. Let's sketch our graphs. Okay, linear we know is a straight line. Oops, I got that kind of off. Quadratic is our U shape. And exponential is our sideways L. So our exponent, if you remember linear, our parent function is y equals x. So our exponent is 1. For quadratic, our parent function is y equals x squared. So 2 is that exponent. And on exponential, our parent function is y equals 2 to the x. So our x is our exponent. Now, we're going to start off by talking about our quadratic parent function. So our quadratic parent function is y equals x squared. So our x values, -2, -1, 0, 1, 2. And then if we put this into the calculator, our y values are going to be 4, 1, 0, 1, 4. So I want you to look at this pattern. You see how it goes from 4 to 0 and then back up to 4? So this we know is our vertex because it's the lowest most point. Now, if we were opposite, it could be the highest most point. So you have to look at your y values to look at that pattern. That's going to be important whenever we start doing the next couple. So -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. I'm going to graph my function. Make sure you put arrows on the ends. Okay, so that's my parent function. So let's go over our different parts. Our vertex is this where it changes direction, or the lowest or highest most point. So our vertex on this one is 0, 0. The vertex is the minimum point, so we're going to have a min statement. So it's a min of 0, because that's my y value, at x equals 0. Our axis of symmetry is that middle imaginary line. That's going to be x equals 0. Our domain is going to keep going on forever in our x value direction, so it's going to be all real numbers. And then our range, which is our y values, I'm just going to start with y. It starts at 0 and it goes up, so it's going to be y is greater than or equal to 0. So those are our characteristics of our parent function. So now we're going to go down and we're going to do another function that is a little bit different. So this one, we have y equals x minus 2 squared minus 4. So tomorrow we're going to talk about how this is our h value and this is our k value, and we're going to use those to find our vertex, and then we can graph it from there. So how we're going to do it today is we're going to type this into our calculator. I'm sorry I can't have a calculator on the screen, but you should have one, or you can use Desmos, okay? So if you use this, Here, let me pull up Desmos really quick. Okay, if you have Desmos, I don't know if you can see this, so I don't know if I have my screen set up right. But you can type in your function. So you type it in right here in your line, and then you go to the little gear button, and there'll be a table that you can hit to get your table. So I'm going to type this into my graphing calculator. If you have one, that's right. So you'll put a parentheses, x minus 2, close your parentheses, square it, and then minus 4. And then you're going to hit second table. So I'm going to do my x, and I'm going to do my y. Now, I want you to look at your table whether you're on Desmos or on your graphing calculator. And at -2, it's at 12. At -1, it's at 5. And it's at 0, 0. Then it's at -3, I'm looking at my y values, -4, -3, 0, 5. So if you see, it went from 12, 5, 0, -3, -4, and then it started going back up. So that lowest most point, so where it changed direction, is at 2, -4. So I'm going to put that in the middle. And then I'm going to do 1, -3, 0, 0, and then I'm going to go in the opposite direction. So I'm going to have 3, -3, and 4, 0. So this right here is my vertex, because that's my lowest most point, and then it went back up. So I'm going to graph these points. I got 0, 0, 1, -3, 2, -4, 3, -3, and then 4, 0. So if you can see, that lowest most point is my vertex. So that is what you're going to be looking for on your calculator whenever you find your table. I'm going to graph it. So on Desmos, if you can see this, I'm just going to show you. If you go to Desmos, type in your function. So I'm going to type in y equals x minus 2. And then your caret and square. And then minus 4. That's what it should look like. So you can kind of see where the vertex is on this, but if you hit this little gear, and then there's the table function, it says convert to a table, it'll give you your table. Now, you're going to have to, it only gives you those points. Well, you can look on your graph, like what those points are too. Where they hit they intersect perfectly. You can click on them. So you can use that to help you. Okay, let's go and identify the characteristics. So our vertex is right here. So that was 2, -4. That is the minimum. So it's going to be a min of -4, because it's my min y, at x equals 2. Our vertex is that imaginary x line, so it's going to be x equals 2. Our domain is all real numbers. And this graph is y, your range. So it's at -4 and going up on our y-axis. So it's going to be greater than or equal to -4. Okay, let me know if you guys have any questions. We will go over this more on the graphing calculator, but do not be afraid to use Desmos. Okay, let's go on to the next page. So this one I'm going to type into your calculator. Try to put this fraction into parentheses. I don't know what just happened there. There we go. So try to put this in parentheses. So I'm going to do parentheses 1 divided by 2. Close my parentheses, x squared minus 2. Now I'm going to do second graph to get my table. So if you look at your table, I'm at negative 2 and it goes 0, negative 1.5, negative 2, negative 1.50. So you can see it goes up to negative, or it goes down to negative 2 and then it goes back up. So negative 2 is going to be my vertex. So 0, negative 2. So this one works out very nicely. And then negative 2, 0. Then I have 1, negative 1.5, and 2, 0. So this one was a little bit easier just because it's kind of like our normal x values. So I'm going to graph this. I have negative 2, 0, which is going to be right on the x-axis. Negative 1, negative 1.5. So you're going to go over to the left, negative 1. Then you're going to go down 1.5. So it's going to be in between that negative 1 and negative 2. 0, negative 2. 1, negative 1.5. That's kind of off. And then 2, 0. So if you can see this one, it's kind of a little bit wider than our other ones have been. So if we look at our function again, see how there's this fraction? That fraction in front is what is making it a little bit wider. So anytime we have a function in front of, or a fraction in front of our x squared, that's going to make it, as we say, compressed. So it's kind of smushed down. And if there was a whole number, it'd be stretched, so it'd be a lot skinnier. And then that negative 2 on the end is what moves it down to the negative 2 on the y-axis. Let's go over our, and we're going to go over that more tomorrow. So we have negative 2 as our vertex, so 0, negative 2. That is our min. So it's going to be a min of negative 2 at x equals 0. Now x equals 0 is also our axis of symmetry, because that's that middle line. Domain is all real numbers because our line's going to continue on. Our quadratic function is going to continue. Now that range is going to be y. Now since it's at negative 2 and going up, it's going to be y is greater than or equal to negative 2. Okay, let me know if you guys have any questions over that one. We're going to go on to the last problem. So this one, we have negative 2 times x plus 1 squared plus 3. So this negative 2 in front, that's what that negative is going to flip it. And then that 2 is going to make it skinnier. And then this plus 1 and plus 3, that's where it's going to shift it to the left and then up. So we're going to type this into our calculator exactly how we see it. You can type it into Desmos. So you're going to do negative 2, parentheses, x plus 1, close parentheses, squared plus 3. Then you're going to second table. Now if we look at our table, it goes, I'm at negative 2 for my x. So I see that it goes 1, 3, 1, negative 5. So 1, 3, 1, I need to go up a little bit. So the negative 1, 3 is my vertex because that is where it changes directions. So negative 1, 3. So then I'm going to put negative 2, 1, negative 3, negative 5. And I'm going to go down and I'm going to do 0, 1, and 1, negative 5. So I kind of want to talk about what I'm seeing. So I see that I go to negative 5, 1, 3. Then I go back up to 1, or go back down to 1, negative 5. So that's how I can see that this is where it changed direction. So we're going to graph those points. So negative 3, negative 5. Negative 2, 1. Yeah, negative 2, 1. Sorry, I had to make sure I had that right. Negative 1, 3. 0, 1. And then 1, negative 5. Oops. So if you can see on this one, because there was that 2 in the very front of our function, it made it a lot skinnier, as we call it. So we stretched it, and then that negative flipped it upside down. So looking at this, our vertex is this topmost point. It's going to be negative 1, 3. This is going to be our max value because it's the top. So it's going to be max of 3 at x equals negative 1. Our axis of symmetry is that middle, which is -1, so x equals -1. Domain is all real numbers. Our range is y. It starts at 3 and goes down, so it's going to be less than or equal to 3. Okay, that is our last one. Please let me know if you have any questions or any problems graphing on that. Okay, last one, our vertex. So you could graph this in the calculator. If we want to do x squared plus 17. Ooh, I kind of messed that one up. Clear. So x squared plus 17. So if you see this, you couldn't even see it on your calculator. But anytime you have an x squared and then a plus 17, your vertex is going to be 0, 17. So if you look at it on your table, it goes 33, 26, 21, 18, 17. So that change in direction is where our vertex is. And then it goes back up to 18 and then back up to 21. Okay, let me know if you have any questions on those.